Ladies and gentlemen, welcome to the first video lesson for Algebra 1 2020-2021. Welcome. My name is Mr. Vesbach, and I'll be the one for the most part doing these videos. These videos are for you to kind of like supplement or enhance your understanding, or in case you miss something or miss a class or need clarification and you can't get a hold of a teacher, you can use these videos to get the information that you need out of the lesson. These lessons are going to be parallel with the notes that you guys have in class. So you picked up a note packet on materials pickup day in the gym, and you guys have notes for each lesson, and I'm going to use those notes in these videos, okay? So if you follow along with these videos, you will be able to take notes. We are also going to be using some of these same slides, not all of them, but we are going to be using some of these same slides in class. The reason that we're not using all of them in class is because we just won't have time to do everything in class. So as we get through the class structure and what that's going to look like, you guys are going to get a better feel for what that's going to be. For now, I just want to show you something that is going to be very valuable as you guys go through here. All right, so this is what I want to show you. You should not be watching this video from start to finish, okay? You should be using this unless you feel like you need it, okay? I'm not going to tell you how to use this tool, but I want to show you a feature here that if you don't need to watch the entire video, if you don't need every single piece of the lesson, how you can get exactly what you want quickly in the lesson. So here's what I'm going to show you. And I'm going to show you a video that I made, oh boy, last year, I believe. This is what I'm looking for. Where did I go? Here. All right. So this is a video that I made last year, and what I put in my videos are little links in the comments, the timestamps to certain problems that are in your notes. And so if you want to go exactly to examples 5 through 8, and 5 through 8 were related, that's why we grouped them, you can click on that timestamp. And I'm not sure if it's going to work right now just because my computer is kind of glitchy. But if you click on that timestamp, it should take you right to exactly where you need to be in that video. So I'm just going to, all right, started, maybe turn the volume down here. So I just click on that 538 timestamp or 524. It's going to bring me to examples 5 through 8, which are now in the video here. So please take advantage of that as you're watching these videos. All right, so lesson 1.1, I'm not going to waste any more time. Let's get at it. You're going to notice that this is not the first page in your notes, and that's okay. What we wanted to do is just kind of get your mind thinking a little bit about something from math, and so we threw some fraction problems at you. What we really want to do is get diving into some of the terms that we're going to use as we go through. So what is a constant? A constant is a value that does not change, and that, constants don't change, right? That it just makes sense. What that means is, like, the number 2 is a constant because it's the number 2. You don't change it. The number pi is a constant. You can't change it. It's pi. It's what it is, okay? So constants you can typically think of as numbers. Variables are going to be the x's, the y's, the z's, the w's, the q's, whatever you see in an expression. It's a letter or symbol that can be replaced by a number. So, for instance, if I have instead 2x, this would be a constant, and x obviously would be the variable. I can later tell you that x is equal to 4, or x is equal to 3, and then we can substitute that value in, okay? One of the things I want to tell you is that whenever we substitute with parentheses. So if I tell you that x is equal to 3, I want to see you writing 2 times 3 in parentheses. Okay? All right. Expression. What is an expression? An expression is a combination of numbers, variables, or operations. So the thing that I wrote before, that 2x, was a very simple expression. I can also put that all over 6 and then add z. That is still an expression. It's just combining operations with numbers and variables. That's it. All right, 39 minutes of battery life is what I got, guys. Hopefully we can get this done in 39 minutes. We will finish in 39 minutes. All right. All right, evaluate. To evaluate means to find the numerical expression of variable. Basically, evaluate means to do as many operations as possible. So do all, I'm gonna move this, operations. I apologize for my handwriting. I'm writing on a slate. I'm going to get better at it. But sorry, that says do all operations. And the best handwriting that I can provide you right now. All right. So that's what it means to evaluate. Now, when we think about doing all the operations, we have to think about an order. This is something that you should know already, but we are going to review it. One thing I'm going to add in. If any time, I'm going to go faster than I would in the normal class. So if you guys need to go back or need me to stop, just hit pause. You guys can do that. You can't do that in normal class. You can hit pause on YouTube. Ready to rock. Okay. So, order of operations. This is the checklist that we run down every single problem to make sure that we're doing things in the right order, because if we're out of order, we got chaos and we will not get the right answer. So we evaluate expressions using the order of operations. This should be review, I hope. So the first one, P, we use this word PEMDAS, P-E-M-D-A-S, to kind of, what's an acronym for the order of operations, right? So what does the P stand for? It's parentheses. Typically, you're going to see them like this, but you can also see them as brackets and other. Also, grouping symbols can be division symbols, right? So if I have a division symbol like 2x over 3y, you can imagine that there are parentheses in the numerator and denominator. So those are all different ways that you can see parentheses. E is for exponents. So we do exponents after parentheses. Multiplication and division come next. We are done from left to right, not just we don't do multiplication just because the m's first in the expression or in the acronym. We do multiplication in order from left to right. So whichever comes first. And we do addition and subtraction in the same exact fashion, right? In order from left to right, whatever comes first. So we're just going to straight up practice some of these, okay? So I'm going to do kind of a you do, I do thing where I'm going to do a problem, I'm going to talk through it, and you guys are going to pause the video and do the next one, okay? I'm going to get to a highlighter here. I'm going to highlight what I have. So our expression 3 plus 8 divided by 4 times 2. So first thing we do in our checklist is, look at it. Do we have any parentheses? The answer is no. Do I have any exponents? The answer is no. Do I have multiplication and division? Remember, these are grouped together, and so are these. And the answer is yes. Now, the first thing I have is division. You don't skip over that just because the m is first. It's whatever comes first from left to right. So the first thing I do is the 8 divided by 4. 8 divided by 4 is 2, okay? And so that's the answer to that problem. So you see me calculating just 8 divided by 4. And then I run down that whole checklist again. I do not have parentheses. I do not have exponents, but I have multiplication. So the next thing that I do is the multiplication of 2 times 2. 2 times 2 gives me 4. And that is done with that. I'm done with that line. And now I go back to the checklist again. I mean, I only have one thing left, right? So it's obvious that I'm going to add, but I don't have parentheses. I don't have multiplication, division. I don't have exponents. I do have addition. So the last thing I'm going to do is the add 3 plus 4, and that is going to give me an answer of 7. Okay? So go ahead and pause the video and go ahead and check your answer to the next one. If you didn't pause the video, that was just some awkward silence, and now you're ready to see your answer. Hopefully you did this. So same exact idea. I got 12 plus negative 24. I changed the subtraction to add the opposite. That's something we're always going to want to do to keep track of signs. So always change your subtraction to add the opposite. I did not have parentheses. I do not have exponents, but I do have multiplication and division. So division is where I'm going to start. And it's right here with negative 24 divided by 8. That gives me negative 3. Notice all I'm doing is carrying down the 12, carrying down the 2 because I did nothing with them. All right. Then I have to go through the checklist again. No parentheses, no exponents, no multiplication, division. All I have left is addition, really. And I do that in order from left to right. So I do the 12 plus negative 3. Right there. 12 plus negative 3 gives me 9. And then all I have left is the 9 plus 12. So the 9 plus 12 is here, and my answer is 11. All right, so those are your first two problems in order of operations. Next one, we get a little bit more complicated because we throw more things at you. So I have 5 minus 1, and in parentheses, I got a 4 plus 2, and outside of that, I got an exponent. Now, as we get more complicated, I don't want you to think of it like, oh, it's longer, it's going to be harder, okay? If you always go back to the checklist, it simplifies what you're supposed to do, because you're only going to do one thing at a time. And what are we supposed to do? Parentheses, right? So I'm just going to tackle that 4 plus 2 first. Well, what's 4 plus 2? That's 6. So there's my answer to that. And then I go through the checklist again. Do I have exponents? I do have exponents right here. So exponents gets to take care of next. And so 6 squared is 36. Notice I didn't multiply by the -1. And also notice I did the changing of subtraction to add the opposite. So now I have a net times -1. Okay. So now I go through the checklist again. I don't have parentheses. I took care of exponents. But now I got multiplication. Multiplication is right here. -1 times 36 is -36. And then all I have left after that is my addition. So I have, let me get down to the video here, down on the screen, 5 plus -36, and that gives me -31. All right, before we move on to the next problem, I want to have a discussion with you that I have prompted on the side. I don't want the highlighter anymore, so I'm going to change my pen. I do want that. Okay. So there is a difference between these two things. I have -x squared without a parentheses, and then I have the quantity with parentheses, -x squared, and then I have parentheses in this one, so that's why I just stumbled over my words. Okay, so -x squared without parentheses, you need to think of it this way. Anytime I have, like here, anytime I just have plain old -x, what that really means is -1 times x, okay? In this instance, what that means is I have -1 times x, and that x is being squared. And if we think about this in terms of order of operations, exponents come before multiplication. And if that's the case, that means that I square before I multiply by -1. However, in this case, this is telling me to take whatever is inside parentheses and square it, multiply it by itself. So this literally means -x times -x. And these two things are different because this is going to be a -x. Oh, sorry, let me get rid of that. This is going to end up being -1 times x. This is completely different than that, okay? So this is going to be -x squared like that. This is going to be end up being a positive value because I'm taking something times itself, and a negative times a negative is positive. So let's see this in action, right? What this means for this one with the -3 is that I have, let me move this out of the way, is that I have a -1 times 3 times 3. Well, that is going to be -1 times 3, which is -3 times 3, which is -9. But now that I add parentheses, this means -3 times -3. And a negative times a negative is a +9. So we get two different results. So that is a very important thing to keep in mind, okay? With parentheses, it's positive. Without parentheses, it's negative. I don't want you to remember the shortcut that I just kind of said there. I want you to remember the process, okay? Anytime you have a negative, it's really -1 times that value. And if you separate that out and follow order operations, this is why we get the difference. Okay, so in practice here on that problem, again, if I'm going through order of operations, I have parentheses here, right? But I actually don't have anything to do in those parentheses. So I'm going straight to exponents. So I have, again, I'm kind of writing this out as we should think about it. It's -1 times that 3 squared. And this we want to think about this as -4 times -4. Okay. -1 times 3 gives me -3 times 3, which is, and I'm kind of just going on the left-hand side here. Can I get rid of this? Which is -9. Okay. So kind of to walk through the process here, this becomes, this negative is here, and then that squaring, right? 3 squared becomes these two things. -1 times 3 times 3. Now we simplify that part, -1 times 3 to get -3, and -3 times 3 is -9. Versus this, again, applying what we talked about over here, because it's in parentheses, it means take what's in parentheses and multiply it by itself twice, because it's 2. If it was 3, then we'd have another one here. So -4 times -4 is 16. So in the end, finishing that problem, I have, let me get a pen here, not the highlighter. I have -9, I'll just finish it over here, -9 plus 16, which is +5. Oh, geez, no, it's not. It is 7. All right. Rough early start of the year here, I guess. All right, so +7 for that one. Okay. So next example, I did not have this one pre-made because I wanted to model how to do this, okay? A couple things. Notice I have put parentheses around here already. Remember the division bar or the fraction bar, or when we have a numerator and denominator, that acts as groupings, right? So this normally was not here. I just put it there because we need to think of it that way, okay? So again, order of operations, parentheses come first. That means I'm going to do the 3 plus 8 first. So 3 plus 8 is 11. That gives me 11 in parentheses squared over 6 times 4. I'm going to put that in parentheses. One step at a time. So parentheses are taken care of. I did one step. Do I still have parentheses? Yes, I do, in the denominator right here. So I'll have that 11 squared in parentheses again. And then the denominator, 6 times 4 is 24. Checklist again. Do I still have parentheses? No, I don't. Done with them. Move on to exponents. Do I have that? Yes, I do. I have 11 squared. 11 squared is 121 over 24, and I'm done with that problem. I cannot simplify that any further. I don't want to mix number. Just leave it as it is. So 121 over 24 is our correct answer. Notice, as I went through this problem, it's really important to say that I kept everything in the numerator and everything in the denominator. What we typically see as a really, really bad organizational thing is that students will be like, all right, well, 3 plus 8 is 11, and that's squared, and then 11 squared is 121, and they do their work this way. And then they say 6 times 4 is 24, and then they bring it all back together over here. When we get into more complicated problems like, this one, that is really hard to keep track of. And it's hard to see your steps. And then if I ask students, like, what are your steps? And they're like, it's kind of this, but and then it's all over the place. Don't do that, please. Work horizontally when you have a large fraction expression to evaluate. Please work horizontally. All right. Work on the next problem on your own and pause the video if you'd like to see the answer in a second. Okay, maybe you paused it. Maybe you saw me stare directly at the screen and that was awkward. That's okay. We're having fun here. All right, so I'm going to kind of highlight what I'm doing one at a time as I go through this. So I do have parentheses. Parentheses are right here, and I have to tackle 4 minus 8. So 4 minus 8 is -4. That's done first. Then I have exponents, and I'm just working the numerator at one step at a time. I'm working everything in the numerator, okay? So I have exponents that I have to take care of right here. And so I have -4 in parentheses squared. Remember, that means the -4 times -4, which gives me a +16. Now I look at this part of it. Do I have any parentheses? No, I don't. So that's done. Do I have any exponents? No, I don't. That's done. Do I have multiplication? No, I don't. But now I have division. I have 16 divided by 16. 16 divided by 16. Now I'm out of space, right? So this is the problem that I'm working on. And I'm just going to move a little bit further down so you can see. 16 divided by 16 is 1. So there's the answer to that light blue problem. And now I'm going to finish off the numerator by saying, all right, I have addition left. That's the only thing left. 8 plus 1 is 9. Now in the denominator, all I have to do is one step. That is 4 minus 1, which is 3. And then the last thing I have to do is just simplify this. 9 divided by 3 is 3. So that one's taken care of. Notice I worked horizontally. I worked the order of operations, and I worked each grouping, the numerator as a grouping at a time, and I worked the denominator as a grouping at a time. Separately, all done individually. All right. Same kind of thing here. I wanted to show this example because it's rather complicated, so you can watch me doing it all the way through here. All right. So what do we got going on? I have two fractions, and I'm going to work them one at a time. And I'm going to do one step at a time. So again, parentheses, exponents, multiplication, division, addition, subtraction. I don't want that. I want like blue or something. And I want it thin. There we go. All right, cool. So I do have parentheses right here. So that 2 plus 4 is going to end up being my first operation that I do. That is then in parentheses. I get 6. It is squared. That's over 2. Plus 12. And then my numerator, I got 3 times 5 over 3. And I'm not even going to worry about that one. I'm going to do that next. So I'm just working this one first. So working that one, I have only one operation. I got exponents. I got 6 squared. So my next step is going to look like 6 squared, which is 36 over 2 plus, and then that whole thing again, right? I'm not going to do anything with it yet. So 12 plus 3 times 5. That's all over 3. All right. I'm out of space, so I'm going to wrap around down here. I'm going to finish this one, and 36 divided by 2 is 18. Plus, and then the 12 plus 3 times 5, all of that is over 3. So now I just have simplifying to do here. Again, I have groupings within that. Remember, the numerator is a group in its own, and inside of that grouping, I have stuff to do. And so I don't have parentheses other than the grouping itself that's there. I don't have exponents, but I do have multiplication, so I'm going to do the 3 times 5. So I have 18 plus, and then the numerator is 12. 3 times 5 is 15 over 3. And now I'm just working this fraction again. 12 plus 15 is 27, so I have that 18 carrying over. It'll give me plus 27 over 3. And now I just have to simplify that 27 over 3 because I can. The last answer that we had before, that was a fraction. We couldn't simplify it to a nice number, so we're going to simplify this one. And that's going to be 18 plus 27 divided by 3 is 9. And so my final answer is 27. Okay, so that's working one step at a time, order of operation, one grouping at a time, knocking it out. Okay, for this one, again, we have that -2 with no parentheses squared. So we're going to pay attention to that when we get to it, but it's not the first thing we do because of PEMDAS, right? So I have exponents, but first we have to do parentheses right there. So -2 squared is going to get done later, plus 2, I'm sorry, not 2. I don't know where that came from. -2 squared, maybe because I wrote a bunch of 2's in a row, plus 3, and then 4 plus 7 is 11. Okay? So go back to the checklist. I don't have parentheses, but I do have exponents right here. So I'm going to do that next. So the -2 without parentheses, I'm just going to write this out. You don't have to do this every time, but this is how you should think about it in your head. Remember, that's -1 times, and now the 2 is being squared, so it's 2 times 2. So -1 times 2 is -2. -2 times 2 is -4, plus 3 times 11. Okay, you could very easily, with practice, and you will get there, go from here to here. I'm just writing out how you should think about it. Okay. All right, and I'm running out of space here, so what happened to my deal? All right, it's back. All right, sorry about that. My writer wasn't working. Okay, I'm gonna wrap around. So now I have -4 plus 3 times 11, just rewriting it. And now I just have this multiplication to do because parentheses exponents multiplication comes next. -4 plus 33. And now I just have to add, and that is going to give me a 29. All right, next one, example 5. Now, evaluating, we talked a little bit about this before. We are always going to substitute with parentheses. Always with parentheses, always, 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 okay? You're gonna see that when we do the in-class portion, maybe you already did, and we're gonna call these kind of briefly, we're not always going to do it, but you kind of think of them as these parking spots, right? We're going to leave a parking spot for the number to go into, okay? So let's look at part A. It says if x is equal to -3, then evaluate x squared minus 5x plus 2. So in this expression, I have two unknowns, x's, and I'm told that x is supposed to be -3. Now, what I'm supposed to do is substitute, and what am I supposed to use? Parentheses, okay? So when I substitute, it's going to be something squared minus 5. I'm going to change that to add the opposite right away, times something plus 2. And those are like those parking spots where now we're going to park that variable value. What is x supposed to be? -3. So that goes there and then there. Okay, so now I've substituted. If you think about that parking spot thing, I've already put parentheses there. It takes care of itself, right? But again, if we did not put parentheses, this part over here, you would have -3 squared like that. And we know that we would get the wrong answer then. Okay, so always substitute with parentheses. That is your main reason why. Okay, so let's get rid of that. Actually, I can just probably click undo. Boom, boom. All right, sweet. And now we just evaluate this. Everything else is the same after we've substituted. So I got -3 squared. That is going to end up being +9. Again, parentheses, exponents, multiplication, division, addition, subtraction, right? That's going to be +9 because I have a -3 times a -3, which is +9, plus -5 times -3 plus 2. Okay, so now I have to evaluate multiplication, 9 plus 15 plus 2, and now I have just addition. So 9 plus 15, that is going to give me 24, and then 24 plus 2 is equal to 26. All right, my battery is running low, so I'm going to speed up a little bit here because I don't want this thing to die on me. I got 10% left. All right, kind of going through this problem one part at a time. I'm going to bring the shade down, and I'm going to use my highlighter. Okay, so if x is equal to -2 and y is equal to -3, I'm supposed to substitute those values here, here, and here, right? So substituting looks like this. So the -2 went here and here in that expression, and the -3 went here. Notice I used parentheses because I had to, and it would mess me up right there. Now, evaluating this, same exact checklist, right? Parentheses, yes, but nothing to do in them. So now I have exponents. Right here, I have exponents, so I'm going to simplify that part. So that -2 that is squared becomes +4 because it's -2 times -2. And then I move on. Next thing I have to do is multiplication. So that 2 times -2 right here, it's done there. 2 times -2 is -4. Drag down everything else. Then I have to multiply the 4 times -3, or -4 times -3, which is +12. Negative times negative is positive. And then -3 times 4 is -12. So that one is that one, and I get 0, okay? This one is one I would hope that you did on your own. You can see how the steps work out. Hopefully that should be good. All right. Last couple of problems here. So Joe wants to upgrade a new iPhone. In 2 months, he is eligible for an upgrade, which would cost him $199. He has already saved $40 and is able to make $15 per week. Will Joe have enough money for an upgrade in 2 months? So when we think about this, we got to think first, like, how much money does Joe start with? Okay. So how much does he start with? He has $40. So he's already got $40. His goal is to get $199, and he's saving $15 a week. So if we think about this in a table, we have it organized into the number of weeks. So week 0 is like right now. He's starting with his $40. We have a calculation that we can do, and then how much money is that going to be? So in week 0, we just have $40. We can say that there's really no pattern established yet because we haven't done anything to establish a pattern, and the money saved is his $40. In week 1, we have that same $40, and we are adding $15 to it. So the pattern that might not look like it's establishing would be 40 but plus 15, and this is where we're going to change the repetitive addition to multiplication. 15 times however many times we added 15, which is one time. 15 times 1 is 15 plus 40. That's going to be 55 bucks. In the second step, you can imagine what's going to happen. I'm going to start with the 40 plus 15 from last week, but now I'm going to add an additional 15. And instead of writing that again, it's going to be 40 plus 15 times 2. 15 times 2 is 30 plus 40 is 70. So now I got 70 bucks. In the third week, we have the same exact thing. We carry down last week's calculation of 40 plus 15 plus 15, and now we add an additional 15, and that is the calculation for week 3. We can simplify that by saying 40 plus 15 times 3, and by now you're probably like, Mr. Vespach, I see what's going on here. I do not have to keep writing this out. I hope you're not filling this out 8 times, because that's how long we have to do this to figure out 2 months, right? 2 months has 8 weeks in it. And you're right, we're not going to. By the time we get here, we're going to say that we have 40 plus 15, ... We're going to just keep adding, right? And it's going to be 40 plus 15 times 3. That's going to give me $100. And then I'm going to go down, and I'm going to skip all the way down here because we know that this is going to be 40 plus 15 times, I said 3 there, that's 4. 40 times 15 plus times 5, and so on, all the way down to the 8th week, okay? And that's going to end up being 40 plus 15 times 8. And that is going to end up giving me $160, okay? And that's the question, right? So after we've done all that, the question is, will he have enough money for the upgrade? Well, it's $199, and after 8 weeks, not 4 weeks, he will only have 160. So the answer is no. He will not have enough money. Okay. Let me get rid of this for a second. Extend the page a little bit. All right, write an expression to show how much money Joe has after X weeks. So let's say Joe's like, all right, well, I have to figure out how much money I have any week, and I don't want to use the table. So what Joe's going to do is going to start out with his $40, and he's going to add 15, and instead of an actual number, he's going to put a variable in here, X. And X is going to be equal to the amount of weeks. So now if X is 10, he can substitute 10 in there and figure out exactly right away. All right. Kristen is starting a business and plans to spend $1,200 in advertising during the first few weeks to help generate business. Each week, she plans to spend $45. Give the amount of money she will have left to spend on advertising after 1, 2, and 3 weeks of advertising. So in week 0, she's going to have $1,200, okay? And she hasn't spent any money. And this is something that a business person might want to do. They might want to think to themselves, like, well, how much money am I going to have in this account as I go on spending money out of it, right? So this is a very real world application. So after the first week, after no weeks have gone by, she hasn't spent any money. So it's going to be $1,200. After 1 week has gone by, how much money is going to be left in the account? Well, that's going to be the 1,200 minus 45, right? And that's going to leave us with $1,155. And then in week 2, we're going to subtract another 45 again. So that's going to leave us with $1,110. And in the third week, we're going to subtract another $45, which is going to leave us with $1,065. Okay. So now Kristen might want to do this to figure out, like, in week 25, how much money am I going to have, right? So again, writing an expression is going to help simplify this. So what's the expression going to look like? We're going to start with the $1,200. And what are we doing? Well, we're subtracting how much? 45. And how often are we doing that? Every week. So W represents the amount of weeks. So W equals number of weeks, or amount of weeks, like I wrote last time. And so now if she wants to figure out how many weeks it would be, if W is going to be equal to 11 weeks, right, she could substitute W in and do that calculation. Quick and easy instead of making a table. All right, next part of the video, the distributive property. Okay, for all real numbers, A, B, and C, the distributive property starts out kind of like this. My PC is running low. I got 6% left. I hope I make it. So we have parentheses with operations on the inside, either addition or subtraction. All right, giving us terms. A is a term, B is a term. What we do is we take what's on the outside and multiply. That's what this indicates, right? Multiplication. We multiply everything on the inside by what's on the outside. So we have C times A, which gives us the CA. And then we have C times B, which gives us the CB. So it gets multiplied all the way through. Again, this should be something familiar. This is here in your notes just to kind of reiterate the fact that, yes, it works with subtraction too. So if you look at the two, there is nothing different. We have A plus B on the inside. This is the same exact thing, but with subtraction. So same rules apply. What's on the outside gets multiplied by each term on the inside. So this is the first term. That is the second term. C times A is CA, and C times B is CB. And again, like these could, C, A, and B can be anything. We're just going to go ahead and multiply them. So again, this is going to look like a you do, I do deal. So negative 11 is on the outside of these parentheses. Okay, this is example 8. And I'm supposed to multiply everything on the inside by what's on the outside. So negative 11 times 5 gives me negative 55. Negative 11 times, I'm going to add the opposite, negative 6 gives me a positive 66W. Now, I could not simplify on the inside of the parentheses, so I did not. And I can't simplify after, so this is my final answer. So I wrote this note here, always simplify if you can first. We could not do that. I don't think you need to watch me do that example again. You can kind of see the results here. Pause the video if you need to see it. I'll do this one, though, because it's a little bit different. I have 2x on the outside times first 5x. So you can think of this, because multiplication can be done in any order that you want. We can think of this as rearranging it. So I can rearrange this as 2 times 5 times x times x. You do not have to physically do that like I did, but you need to think of it that way, because what we do is we multiply the 2 times 5 together to get 10, and the x times x simplifies to x squared. And then I multiply the 2x times, again, I'll add the opposite, negative 3. So that's going to give me a negative 6x. And now I can't simplify, so that stays the same. Again, another example for you to look at. You can work through and see how it shook out here. All right, number 9. I have negative 4x squared. I'm sorry, negative 4x on the outside parentheses times x. So negative 4x times x is going to be a negative 4x squared. Negative 4x times 3 is going to give me a negative 12x. Now this was not inside parentheses, so I did not distribute to it. It just goes along for the ride, but I am going to add the opposite like I had before. But now notice I have some like terms. This was supposed to be an x, by the way. And now I have some like terms, so I can combine like terms here and here. So I'll have a negative 4x squared plus a negative 18x. These are not like terms, so I cannot combine them. Again, you can look at this one for your viewing pleasure. The same exact thing happened. One thing here is that I wrote this 9y over there. I just shifted it over. All right, last example here. I have 7x plus 4 minus 5x plus 6. So the big deal here is that this is a negative. That negative is going to get distributed here, just like the 7 is going to get distributed here. Okay? So I got 7x plus 28. And then I have a negative 5x. It's negative 1 times 5x, so negative 5x. And a negative 1 times 6, so plus negative 6. And now I have to combine like terms. That is going to give me a 2x plus 22. So again, I cannot combine like terms. This is what I'm left with. Here is this one for your viewing pleasure. I am going fast because my computer's about to die. Don't die on me. All right, and the last problem here. Distributive property to find the area of a rectangle that has length of x and width of 2x plus 4. So if the length is x and the width is 2x plus 4, The area formula for a rectangle is length times width, something you should know. Now I have to just substitute in parentheses. Length and width don't matter. So I have x, say for the length, and the width, which is then the other one, which is 2x plus 4. So now I just got to distribute, like I had here. This is kind of bringing everything together, right? Substitution using parentheses and a distributive property. So x times 2x gives me 2x squared. X times 4 gives me plus 4x. And that is as simple as I can go. This is my final answer. All right, ladies and gentlemen, I hope that you found this video informative and that it helps you. I hope you use it appropriately using the timestamps. Have a great one.